Our target today is to determine the domain and range of a function. Just to review, the domain can be thought of as the x, the inputs, and the independent variables, and the range can be thought about as the y, the outputs, or the dependent variables. In example 1, it says find the domain and range of a line segment P, -2, -3, and Q, 4, 1. So obviously our first job here is to graph the line segment. You'll notice that it has a beginning and an end. So if we look at the domain refers to the x values. The x values can be highlighted in between P and Q, as you see on the screen. The numerical values that go along with these boundaries would be -2 and 4. Therefore, the domain, as defined by x, is going to be in between -2 and 4 and including those numbers. Now, if we talk about the range, we're talking about the vertical component. So if we look at the purple box you see on your screen, the line segment is constraining those y values, and they are going in between -3 and 1. So therefore, our range, as defined by y, would be in between -3 and 1, and including those 2 points. If we put this together, you'll see our domain and our range written out on the left. And on the right, if you think about a line segment, the domain and range is constrained by this yellow box. In example 2, it says find the domain and range of array LS. So array LS starts at the initial point L, goes through S, and you'll notice the arrow on the end does not terminate. Therefore, if we look at the domain starts at L, and it goes off the graph to infinity. So therefore, we can think about it going to the right, or to positive infinity. Therefore, our domain is only restricted in the sense that it has to be greater than or equal to the -3 value. Okay, let's clear our graph. Let's talk about the range. So the range can be thought about in this problem as a ceiling. It includes all the points below the L value. Now these points go to infinity in the negative direction. So therefore, our range is as defined by y, as y is going to be less than or equal to the 4 value from the L. Putting these together, the domain and range of this function are as seen on the left. So we've done both line segments and arrays, and you might be asking yourself, well, the next thing we want to talk about is lines. So if in example 3, it says find the domain and the range of a line VS. If we look at V and S, you'll notice on either side, there's arrows going to infinity. So we have to count all the values on the x-axis and all the values on the y-axis. So this would be written, the domain is as defined by x, as the set of all real numbers. So this R means all real numbers. And the same thing with the y value. There's no beginning and end, like the line segment or the array. So here's an example of a function that we're going to see later in the semester. It says, what is the domain range for the given function? You'll notice that I used a computer program to graph this. When using a computer program, it doesn't put arrows on the end like we write in class. So we have to add those. Knowing that, the arrows go up to infinity. If we think about this bottom being 2, -3, or like a glass, it has a bottom, there's nothing below that bottom, but there is something above that bottom. And that's controlled by this y value, this -3. So therefore, the range is y is greater than or equal to -3. The domain, going back and forth, if these arrows go to infinity, it's going to include all those values of x. Just like the linear function we saw in the previous problem, the domain is going to be a set of all real numbers. So I have 3 functions in front of you, a, b, and c. I want you to pause the video right now and see if you can come up with the domain and range of both a, b, and c. In c, you can assume this never crosses the x-axis. Okay, hopefully your answers match up to mine. the first problem, we have a horizontal line. The domain, or the x values, is a set of all real numbers because I have arrows going on both sides. In the range, it's only equal to -2. In the second one, for the vertical line, the domain is -3, and the range is a set of all real numbers because it goes up to +infinity and down to -infinity. This is an example of a function we haven't seen before, so hopefully you took the challenge on. The domain, and as I said, it's not going to cross this x-axis. The domain is going to be the set of all real numbers going that way, going this way. The range, it's going to be greater than 0. It never crosses that x-axis, so it's always going to be above. It's always going to be a positive value. Okay, I want you to do the same thing. I want you to pause the video again and see if you can come up with the domain and range of this function. And hopefully, just like the parabola we saw, you'll notice that there's a bottom like a glass. So that point right there is 1, -2. We don't have to worry about the x's because they go to infinity in both directions. But the y is the bottom. So the domain is going to be the set of all real numbers. The range is going to be y is greater than or equal to -2. So in your own words, I want you to pause the video right now and describe in your own words what you're looking for when you determine the domain and range. Some people think of it as in a window. Some people think of it as a point specifically they're looking for. Hopefully through this video, this helped you determine the domain and range of a function.